I think we should get going. A warm welcome to everyone from the Israel Trade Mission here in Berlin. We're very happy to have a great audience today from Germany, Israel, and Europe. My name is Simon Steffgen, and I work as a trade officer here in Berlin, where I'm responsible for the energy and cleantech sectors, among others. To accomplish and master the energy transition towards sustainable infrastructure is becoming more and more urgent every day. We would be very happy to foster this change by facilitating the connections between Israeli innovation and the German industry. Before we get started, let me shortly introduce our office as well as our partners. As you see behind me, we are happy to have several institutions on board. First of all, our dear colleagues from the Israel Export Institute, namely Hila Liebman. It's always a pleasure to work with you. Also, we have SME management as well as the Elia Group and 50 Hertz, who will be present as speakers, and they also spread the word of today's event in Germany. Thank you for this as well. So, who are we? The Israel Economic and Trade Mission is the outer branch of the Israeli Ministry of Economy and Industry in Jerusalem. We represent the Israeli industry in Germany, and we are part of a worldwide network of 45 trade missions. We help Israeli companies enter the local markets. We spread the word of Israeli innovation in all sectors. And we also offer scouting for Israeli innovation for any German company interested. This we do for free because we are a publicly funded institution. So please feel free to approach us anytime. What can you expect in the next 2 hours? After a keynote by Esche Liebman from Ignite the Spark, we will listen to Esther Elias, the commercial consul and head of the Israel Trade Mission in Berlin. She will introduce the recently signed energy partnership between Germany and Israel. After that, we will listen to our first pitching session and hear 3 Israeli companies. After this session, we will hear short presentations from Dr. Stefan Röder and Sebastian Koppenholle and get to know developments in the German and European energy transition. We'll also have a short discussion with both of them afterwards. Finally, we hear another 3 pitches to round the event. As you can hear, we have a tight schedule today and hope to provide lots of helpful information to our dear audience. If you have questions, please feel free to type them in the chat. We will either reply in the chat or pick up the question in the pitch or the discussion. So without any further ado, I'm now very happy to introduce to you Esche Liebman, who is co-founder of Ignite the Spark. They are the Israeli energy tech community and created the energy map together with the Israel Export Institute and Startup Nation Central. Esche, we're very happy to have you here today and look forward to your presentation.
Hi everyone, good afternoon. Simon, Hila, Esther, and everyone involved in making this event happening. Thank you so much for this opportunity. My name is Esche Liebman. I think Simon has already presented me pretty well, but just let me know if you can see my screen.
Yes, we can.
Perfect. So I'll try to be brief as much as possible because there's a lot of energy in this call, and I think probably I'm the least interesting person in the room. But so I made a short presentation to try and explain to you, A, what's happening here in Israel when it comes to energy tech, and B, how it differs from what's happening now in Germany. The word Energiewende, okay, I hope I pronounce it right, means probably a lot to all of the people that are participating in this chat. Now, it's amazing that a movement and an idea that began 22 years ago in Germany is now translated into the energy transition and famous globally. But Energiewende doesn't translate well to Hebrew. And the reason is, and the only way that we can translate it into Hebrew would be something that sounds like energy revolution or mahapechat energia, because it just doesn't, we cannot find the right words. And sadly, not many people in Israel are familiar neither with the term Energiewende or the energy transition. And I thought to myself, what are the reasons? And I made a very small comparison between the German and the Israeli energy markets. So in terms of, let's look at any energy supply chain. In terms of generation utilities, we have 4 huge utilities in Germany that are manufacturing energy globally. We have, 4 TSO, I'm not sure why there is one, 50 hertz, one of them is here today. We have Amprion and Janet. We have over 900 DSO, distributed system operators, and over 1,200 suppliers, energy suppliers in Germany. Now try to compare that to Israel. Yes, both by size and population, we are smaller than Germany, but we have huge vertical utility called Israel Electric, the Israel Electric Company, which is both the biggest energy manufacturer, the only TSO, the only DSO, and the biggest supplier. Now, luckily, there was a big reform happening in Israel that quite unbundled the energy, the local energy market, but still, I think that the structure of a very vertical governmental-owned company that owns most of the electricity market here in Israel has caused us for some isolation. Not isolation from the COVID as we know it, but isolation related to the fact that we are not trading energy with any other neighboring country, except for a tiny line of 20 megawatts between Jericho and Jordan. We found a lot of gas, natural gas, over the last decade that allowed us to basically portray natural gas as a greener energy and put most of the focus over there. Yes, I know that most of Europe is jealous in Israel for the relatively comfortable energy prices that we have, thanks to the fact that we have some domestic gas, but still, it allowed us to move most of our investments away from new energy-related technologies. I think also the fact that there is no apparent win story or a huge success story of a renewable energy tech company, and we can talk about the SolarEdge story afterwards. So all of that has caused Israel to be, in a way, a few steps behind the rest of the world when it comes to energy technologies. Now, after saying some maybe not the most appealing description of what's happening here in Israel, I'm happy to open this webinar and tell you that everything is changing now. And mostly the speakers that will come after me will prove that. But the reason why there is such a big change is because we are no more an electric island, thanks to a great deal fostered by both Israel, Jordan, the UAE, Masdar, that renewable energy produced in Jordan will be sold to Israel in returns to water being sold back to Jordan. There is a big reform that is happening now, as I mentioned before, in the local electricity market that allows both new generation, both renewable and conventional, to be added to domestic system. We have new ISO, Independent System Operator, or NOGA, that is now helping all of those players to find their role in this changing energy market. Different natural gas and oil and gas players are now looking into new technologies, specifically in hydrogen and carbon capture, utilization and storage fields. I think in Bazan, Bazan, the biggest company making petrochemicals in Israel, is responsible with that. Obviously, picking up global trends after COP26 and understanding that climate warming is serious, but also, and most importantly, there are some new interesting ventures. I hope I'll be able to speak about some of them during my talk, but you're going to meet many of them afterwards, that are now being formed in Israel. So I am optimistic, but there are still many challenges ahead. A report published by our ecosystem, Ignite the Spark, basically shed the light on the fact that there are still four main pillars that Israeli energy tech companies are still facing. in terms of funding, in terms of the access for trained personnel related to energy tech research, in the form of regulation and governmental support for energy tech companies to basically build pilots and deal with different institutes. And the last one, a scale-up problem, which is serious because most of the startups in Israel doesn't really have the market domestically. So in many cases, it will make no sense to create the pilot site or even the scale-up site in Israel. And I hope that thanks to this webinar, I will create some new synergies that will allow both the Israeli and the German ecosystem to grow. So with no further ado, this is the energy landscape map made as the collaboration between Startup Nation Central, which is a non-profit, mostly dealing with the dissemination of the Israeli tech word globally. Ignite the Spark, which is the Israeli energy tech ecosystem, and the Israel Export Institute that are organizing this webinar. And on this map, you can see almost 100 companies in the 4 main pillars of the energy supply chain. We have the generation part, okay? And you can see this illustration, but although I guess that most of the people that are here are quite familiar with it, we have the generation part, the T&D pillar, the consumer or last mile, and the storage. And this map is an updated map that was published only 2 months ago. And we added 2 different sectors. One of them is hydrogen-related technologies, and the other one is carbon mitigation, both carbon capture, utilization and storage, and waste to energy. So what's unique about this map, and I'm sure that Hila will send all of you in the end of this event a link to the dynamic map, is that whenever you're looking for specific technology related to Israeli innovation in energy, you can click on the map and then click on any different company which is on the map. You can understand exactly what this company is doing and what is their related technology within this small glossary you see here on the right side of the map. And the moment that you click on the map, you will be directed immediately to the final page that is basically giving a further description of what is the company is doing and how to get in touch with those companies. And if that's not enough, I think both the Trade Mission, the Israel Export Institute, and us will be more than happy to connect you and give you some more information for companies that will be relevant to your core business pillars as well. Let's try to break it down. What is this Israeli tech sector is consist of? So we have overall over 180 startups, divided actually quite neatly between the 4 pillars, where I think that the leading technologies that are currently, let's say, pushing forward the Israeli energy tech scene are mostly solar energy. Not surprising. We have more than 1,800 sun hours annually in Israel. It's at least 200 more than in Europe. So solar energy is both PV cell technology, PV model technology, inverters, smart ways to monitor both utility and distributed energy installations, and autonomous cleaning. We have on the T&D side a clear affiliation with OT cyber companies. So everything related to the protection of critical infrastructure or operational technology is very good. But we have several very interesting grid monitoring companies allowing both to forecast demand, forecast congestions, and also do some algo trading in regards to how to plan those energy contracts that they're dealing with. On the last mile side, so not surprisingly, everything related to energy efficiency and the best way to heat or cool both domestic and industrial plants. And on the energy storage side, so quite surprising, but we have a lot of bad lithium-ion and other alternative to lithium-ion technologies that allows us basically to find the best and the brightest chemistries for the batteries and other storage technologies of tomorrow. Another interesting trends that happened recently is that on the left side, you'll see some famous, more and less famous IPOs and exits that happened, some of them a few years ago, some of them like Drives or Metricom recently. Those were amazing deals and amazing companies. And on the right side, and some of them are actually with us today, we see companies that IPO'd as a method to raise money. And it is really interesting to see this trend that basically, because of another problem that we have in the ecosystem, that there is not a lot of capital that can be injected into companies, and specifically not scale-up capital. Many companies harnessed the market conditions and IPO'd over the last 18 months, some of them even more. So I don't have much time. This is a very brief overview of the Israeli energy ecosystem. So we have several incubators, including a new incubator, which is called Net Zero Technology Ventures, that can invest up to $1 million into a company. There are several other VCs and CVCs. This is not updated. There are actually many more CVCs that entered our ecosystem recently. Some opportunities for non-dilutive funding, including, and that will be the most relevant for this call, some consortiums from the New Horizon programs and the EIC program that I think is very relevant for everyone who's on this call, and several other stakeholders. There are different cool technologies that are not on the map and right now in stealth mode, such as green hydrogen produced with quantum dots, which is a technique that basically skips electrolyzers, room temperature superconductors, fusion company, which is developing fusion in a box, a fusion system inside a container, drones that are able to support the efficiency of wind turbines and solar plants, and many more. A word about Ignite the Spark. We are trying to foster and help companies grow, but also create the new generation of energy entrepreneurs here in Israel. And we'd be more than happy to find partners or similar ecosystems in Germany. So feel free to reach out if you can create smart connections and create very straightforward, non-monitored networking with other stakeholders. Exactly, this is our main goal. And I look forward to listen to all of the interesting talks and the different companies that will be pitching here today. But the most importantly, keep your energies and find amazing partners from Israel, because there are amazing companies that are waiting to collaborate, grow, and scale up to Europe and specifically to Germany. And we have a lot to learn from you. So thank you very much for the opportunity to speak here today. And I look forward for the next talks.
Thank you very much, Eshe, for this highly interesting and crisp presentation. Thank you so much. Very, very interesting. Yeah, dear audience, if you have questions, please feel free to type them in the chat. You can also feel free to introduce yourself in the chat and connect to the other participants. And now I'm very happy to hand over to our next speaker, namely Esther Elias. She's the commercial consul at the Israeli Economic and Trade Mission here in Berlin, and she's leading our office. And yeah, thank you, Esther, for being here today and presenting the recently signed energy partnership. The floor is yours.
Thank you, Simon, and thank you, Eshe, for the energetic presentation. Right, we're talking about energy today. So first of all, I would like to thank you all for joining us today on behalf of Simon and myself and the Economic and Trade Mission to say that the energy sector and the clean tech in general is a huge topic in here. There is a great potential, as I will explain in a few sentences in a few minutes. And we're very happy to start this collaboration regarding the new energy map. And as Simon mentioned, we can help you with various ways. So just feel free to approach us from both sides, from the Israeli side and from the German side. So after this comprehensive presentation of the Israeli ecosystem, and as we heard, as we're talking about the Israeli innovation, out of necessity came the innovation. So this is basically the story of the Israeli innovation and the Israeli ecosystem. I would like to explain in a few words what is the energy transition here in Germany, and then I will give you a few words about the joint declaration that was signed last month, and then we will continue to hear about the great companies in here and the great German side story from our German guests. So as was mentioned by Escher, I think that the energy transition here in Germany, or as I heard, started back in the 70s. And this is basically the movement from the rely on energy system dominated by fossil and by nuclear fuels towards an efficient and sustainable energy system that will based on renewable energy. So this is, to make a long story short, what is the energy transition here in Germany. So as I mentioned, the effort started back in the 70s, and Germany is trying to make a revolution in terms of renewable energy. And there is some reasons why Germany is doing it. So first of all, of course, because of the climate changes and because we want to have a better world, better environment to live in with all the things that related to that. But there is also some other reasons. So the first one is obviously the part that Germany is taking in the world, in the economic world, in the politician world, in Europe, in the European Union. Germany obviously is a leader, and the success of this process of transforming Germany to a greener country will also affect the countries around us. So basically, if the process will be successful, many countries will follow Germany in the process. So this is also one of the aspects of this process. Obviously, there is also some political issues that are affecting this energy transition. We can see what we're having these days between Russia and the Ukraine, but not only. Germany actually wants an independent system, energy system in the country that also will affect both the economy, the way that people are living in Germany, and the way that people are living in Europe and in the entire world. So after this long words about the energy transition, a month ago, after seeing what we can, as Israel, can learn from the German side about what we can do about cleaner energy, renewable energy, and everything that Escher mentioned a few minutes ago, Israel saw and thought that Germany is a great potential partner to do better things with the energy sector. And Germany, on the other side, saw Israel as a leader for technology, for energy technology, for clean tech technology, and the complementary aspects that we can gain from this partnership. So a month ago, as I mentioned, the Ministry of Energy from Israel, and I hope I will say it right, the German Parliamentary State Secretary of the Federal Ministry of Economic Affairs and Climate Action signed this agreement, this declaration in France. And basically it means that both countries are pushing the sides to cooperate more. So it has both political aspect, but also a very economic and business aspect. So from the political side, it means that both countries, if they push the sides to cooperate, funds will come. So we don't have funds yet, but we can expect them to come. It means funds for projects, funds for research, funds for POCs together. And also, it also named under the declaration that as part of this, joint declaration, the two sides will have workshops, delegations into Israel and to Germany, events, and everything will be under this partnership, meaning both sides also will fund it. Also, the declaration also defines some topics that they urge the two sides to work on, among them the electricity market design, the hydrogen strategic, energy efficiency, cybersecurity for critical infrastructure, and many others. And again, they push the sides to do things in order to promote these two topics within the two countries. Germany, Israel doesn't have many partnerships like this, especially around energy. So putting Germany first on the map means how much Israel considers Germany as a big, big partner in terms of energy. Germany, on the other side, has 20 other partnerships with other countries, but unlike the others, with this one, Germany is actually calling for cooperation around the technology, meaning Germany has a lot to teach us about what we can do regarding renewable energy, but is also willing to learn what we can contribute to the table from the side of technology. And this is why we also have this declaration today as part of this event. As I wrote here, from business opportunities and how can we assist you? Since the declaration was signed a month ago, we really urge you, now it's the time that we design how we're going to actually take actions out of this partnership and out of this declaration. So if you have any suggestion or any idea about how we can cooperate, what you would like to do with the German side or with the Israeli side, if it, for instance, hackathons or POCs, or you're looking for partners for each side, we're here for you. In addition to that, we're going to be partner of any event that is going to take place within the energy sector in Israel or in Germany. So if you're planning to take part in any of those, please let us know, and we will try to also gain you some added value. For instance, for eWorld that is going to take place next month, or for Intersolar, etc. And again, as Simon mentioned, if you have any idea about what do you want to do in Germany, you're looking for a business partner from both sides, we're here for you. Use this declaration wisely. If you think you have any idea and you need funding, please let us know, we will try to assist. And there are no stupid questions. Like, if you have any idea, just talk to us. Worst case scenario, we will say, we can't assist. So thank you very much, and moving forward to the companies.
Thank you very much, Esther, for these explanatory words. And yeah, it's an exciting beginning now. We're very much looking forward to develop and design concrete actions. And yeah, this is a good way to connect today. Thank you very much for this. Now, I would like to hand over to Hila Lippmann. Hila Lippmann is the head of the energy and cleantech sector within the Israel Export Institute. And we are cooperating with her on a regular basis. And yeah, she organized this event today with us. Hila, I'm very happy to have you today. She will present the Israeli companies. And yeah, very much looking forward, and please, the floor is yours. You're still muted?
Now you can hear me.
Okay,
right?
Now we can hear you perfectly. Okay.
Thank you
great.
so much, Simon. Thank you. Good afternoon, everyone. My name is Hila Lippmann. I'm the head of cleantech and context sector in the Israeli Export Institute. Very shortly, we are a non-profit and semi-governmental organization that assists Israeli startups to pursue for business opportunities across the global markets in over 10 different industries, such as energy, of course, agri-tech, cyber, and many more. And no doubt this event occurs in an exceptional time when Europe is in general and Germany in particular pushing hard for rising the energy production from renewables in order to cut reliance on fossil fuels and increase energy independency in general. So I'm really all hope this event will give our participants here an idea or thoughts about how to foster the cooperation between the two countries to reach this novel goal. So I welcome everybody here to contact me directly at the matter at hand. We are open for discussion and open for collaboration. So you're more than welcome to talk with us. And of course, I will take this opportunity to thank Berlin Economic Trade Mission Office for this joint effort, creating this wonderful event. And now for the presentation part, I'm glad to start with the grid and the transmission pillar. And I'm proud to welcome Dr. Ervin, the founder and CEO of Prisma Photonics. Ervin, the floor is yours.
Thank you very much, Hila, and thank you, Simon, and thank you, Esther, for inviting us to this event, to take part on it. And I would like in this presentation to review the ways of monitoring critical infrastructure using an optical fiber. And maybe the best way would be to start with the best way to explain a complex matter would be with a simple example. And this is a story of a specific tower located in California. And if I will take you back to November 2018, there was a single failure on this tower in the transmission line of California. And this single failure initiated a wildfire. And eventually this single failure evolved to be the deadliest wildfire in California ever, with tens of people who died, with tens of billions of dollars in damages, and eventually bankruptcy of the Californian utility. Everything started with a single failure in a critical infrastructure. And this is exactly what we are coming to help and to solve. And we're giving a solution that enables detecting in real time and with precise localization any failure along a transmission line, and also to detect side effects like wildfire. But it can do much more than the two of those. It can give indication about, for example, extreme wind, lightning strike, icing, aspect of vandalism, of course failure, but also predictive maintenance. So before the problems evolve into a failure, we can give indication about the problem and the precise localization of it. I would just say in a high level that this solution is relevant to almost any kind of long critical infrastructure. But of course, in this talk, we're focusing on the electricity and the transmission line. And let's explain a little bit how the solution is look like. So if you would like to monitor a transmission line, you can use, multi-sensors installed on the grid itself, on the towers that you can see on the right side. But when you're speaking about big scale, about thousands of kilometers, that's become very, very complicated and expensive. And the ramp up time is very, very slow. And what we're doing is basically we're using as sensor the pre-existing optical fiber, a fiber optic cable that is already part of the transmission line. So there is no need to install any sensor at all. And while we are plugging our system into this optical network, a single system can turn 100 kilometers of fiber into high precision sensor. So it's a very simple installation that practically designed to scale big. And there is a lot of benefit. Of course, there is a very fast deployment, plugging a system and then immediately 100 kilometers turn into smart infrastructure. And since we don't need to install anything, the cost per kilometer is very, very attractive. And of course, we can detect a lot of aspects. It can be safety, security, maintenance, and even predictive maintenance. I would mention that when we're speaking about thousands of kilometers and more, we're speaking about multiple systems that are connected into this fiber optics, but everything eventually is presented in a single and consolidated user interface. So the utility can see the whole picture of the whole network, whatever it's 100 kilometers or 10,000 of kilometers. It's important to say that I mentioned overhead transmission line, but this technology is also highly relevant to underground high voltage cable, and it can give failure localization. This is very important when you start to dig, mainly in urban environment, and digging is very complicated, expensive. So we can give a very precise localization in a resolution of few meters. We can do aspect of predictive maintenance. So before problem evolve, you can deal with it. And also third-party activities. If someone else is risking the electricity infrastructure by digging or walking close by, we can give an alert with precise localization and prevent a potential problem. Another interesting aspect is that two months ago, we announced that we closed a 20 million investment round, and one of the investors in this round, or the participant, was E.ON, the German power utility, probably the biggest utility in Europe. And for us, having them participating in our finance round, this is a very significant vote of confidence from such a strategic player in this industry. We're working or deploying this technology globally, starting in Israel with a cooperation, and even recently participated in our investment around the Israeli Electric Corporation, but also in North America with partners like the New York Power Authority, and also in Asia Pacific with partners like Tata. The company started in 2017. We are 40 employees. We're growing fast. We aim to double this headcount by the end of the year. And I think that the main asset of the company is the team. We have a very strong technical team, real deep tech, from laser physics to machine learning and algorithm, but also strong management with a vast experience taking startup from incorporation into global leadership. Just to summarize the main 4 bullets, what we're developing practically is a new standard for long infrastructure monitoring. And this is something that really can scale up for a solution for thousands of kilometers, because there is no need to install any physical sensors. We can use pre-existing fibers that practically behave as our sensors. We also implemented an innovative business model, which we're offering sensing as a service. Therefore, the utility don't need to invest in day one, big capital expenses, but just can, use it as a service and grow with it as the solution expand throughout the infrastructure. And I would say that this is a proven solution, which tested, validated, and installed by various Tier 1 clients globally. So thank you very much, and we will be glad to answer a question either in this session, but also to follow up with anyone that's interesting later on. Thank you.
Thank you so much, Ervin. And we are moving on to our second pillar, which is carbon mitigation. And I would like to introduce you to Inbal Kan-Tor, Head of Carbon Capture, Utilization, and Storage Business in Airovation Technologies. Inbal, the stage is yours.
Thank you very much, Hila. Let me make sure I can share properly. So, hello everybody, guten Tag. We are going to talk now about carbon to value and the enablement of the circular economy. And the way we do it is by capture carbon and mineralizing it. So the bigger problem, if we look at numbers, is that every year over 36.4 billion metric tons of greenhouse gases are emitted into the atmosphere. Out of that, 65% is carbon dioxide. Now, if we drill down into the sector, the most polluting sectors, we see that the energy sector has the greatest emissions, specifically energy used in the industry. So after 10 years of research by the Hebrew University in Jerusalem, a group of chemists led by Professor Yoel Sasson managed to stabilize superoxide radical, which is the strongest oxidizer known to man in nature, inside liquid phase. So what it actually does, it converts the carbon dioxide that is being captured into minerals. And those minerals are used as raw materials in many industries. So this is how we create the circular economy by providing those raw materials to the food and feed industry, pharmaceutical, fertilizers, also glass industries. And this technology is already patented. We have 2 patents, a very vast know-how, which is even more advanced the patents that are currently registered. And a bit about the journey that we passed so far. So we talked about the 10 years of research in the Hebrew University. In 2017, we received the exclusive license. And since then, we launched another patent. In 2018, we had our first lab demonstration in the Underwriter laboratories in the US. In 2019, we had our first field technology demonstration in collaboration with the Israeli Ministry of Environmental Protection. And last year, we signed a collaboration agreement with the biggest manufacturer of raw materials for our chemical reaction. And that manufacturer also decided to become an investor of Airovation technologies. This year, we are working on our first phase 1 here in Israel, scale up, and we are in the process of signing multiple international MOUs in Europe, Italy and UK specifically, and in Korea. Now, the test in the UL laboratories, I hope you will be able to see the video running. So what we did, we built a room, filled it with furnitures, and then burned it, because different furnitures have different emission profiles. And we wanted to see how the technology can react to many different substances enter into it. And what you can see here, that from everything that entered into the reactor, only less than 1 ppm came out. So if we look at the right side of your screen on the graph, the red graph describes the concentration of CO2 that entered into the reactor during that live test. So you can see that at the top of it, at the peak, the concentration was around 17 to 18% of CO2, while the blue graph below describes the amount of the concentration of CO2 that came out of the reactor. So we actually saw mineralization of 99.5% of highly concentrated CO2 during that live test. Is this stuck? Okay. So where we are currently at, the technology level is TRL6, meaning we had the technology demonstration in the certification lab and also the field demonstration. This year, we are planning to start the scale up of capturing 150 metric ton of CO2 per year. That would be the reactor capacity. And then next year, we will commence the phase 2, which is already building the full modular unit, which will be built into 40-feet containers. And the capacity will be to capture 5,000 metric ton of CO2, concentrated CO2 per year. The idea behind the containers is that, first of all, they are easily mobilized around the world, but also you can stack them up to 4 containers on top of each other. So there's much thinking going into retrofitting, because we are aware to the fact that many factories will have to retrofit, and we are being very conscious for the footprint. Also, because of the high kinetic of the reaction, we are able to compress everything into one container. And so the scale up stage after that will be the commercial stage, which will be just chaining those containers to each other. So if we want to capture 25,000 metric tons of CO2 per year, we will need 5 containers, 5 modular units to do that. This is an illustration of the modular units. Here they are sitting side by side, but again, they can be stacked on top of each other. And just to summarize the key competitive advantages that our technology has is, first of all, very high grade, valuable minerals, as I mentioned, that can be used in the food and feed industry and pharmaceutical, as well as other less demanding industries. Also, our conversion rate is over 95%. We capture the carbon directly from point of source. And this is why we can, because we can use this reaction with highly concentrated CO2. The high grade minerals enable the circular economy. Also, the power requirement is very low comparing to other technologies that are currently being developed. And this solution requires no pressurizing, no sequestration, storage, or transportation, which in many countries, and especially Europe, sequestration is not an option, as it is, it can be too dangerous. And so this is the probably valuable solution. Our partners are UNIT, which is a daughter company of OCI, Dreamstone Partners, the Yosva Group, and Agar Corporation, which is a Canadian company that manufacture measurement equipment for the oil and gas industries. We are currently looking for partners from the EPC sector and manufacturers of gray hydrogen that are interested in converting the gray hydrogen into blue hydrogen. And we will be very happy to hear any question you might have, or any idea is welcome. And thank you very much for listening today.
Thank you, Inbal. Thank you for presenting us this fascinating technology. And we would like to move on to our third pillar, which is the consumers. So I would like to present you to Ido Benyehuda, Head of Marketing in Augwind. Ido, go ahead.
Hello, everybody. Just a second, let me know if you can see my screen and if you can hear me well.
We can hear you perfectly.
And see the screen?
Yeah.
Okay. So hello, everybody again, and thank you very much for the opportunity and the invitation to participate in this interesting webinar and talking about Israeli innovation for energy transition. I'm happy to introduce and represent Augwind. Augwind is an Israeli energy technology company that was established, founded 10 years ago with the vision to develop a sustainable, cost-effective, and I would say safe energy storage solution. In short, the story is that our founder was working in California in a company called eSolar some 10 years ago, 11 years ago, in the early days of solar energy in California. And while driving across the San Giorgino Ridge, he saw wind turbines that are standing still in the afternoon, and coming back later this evening, he saw the same wind turbines, or later at night, spin. So he thought to himself that there is some kind of a conflict here, because when you need electricity, the turbine stood, and when you actually sleep, the wind spins the turbines and generate electricity. And being a mechanical engineer specializes in thermodynamics, he visualized a component that would be buried underground underneath wind turbines and will be able to store the excess energy in the form of compressed air. So from here is the word Augwind, augmented wind. They started to develop the core component, which is the underground accumulator for the compressed air. And while developing the system, he found that the same component can already be commercialized for a product in the compressed air sector, in the manufacturing sector. So there was a spin-off technology to a line of product that's called Air Smart, and now is the air battery. So the company today has a core technology that is the basis for two innovative lines of products. One is the air battery for the energy storage, and the other is the Air Smart for industrial compressed air operation. And today, given the title of the webinar, we're going to focus on the air battery energy storage. So in brief, energy storage and the drivers, the needs for energy storage. I'm sure that you are well aware, integration of renewable energy must have some kind of a buffering component that would balance between energy generation and energy consumption. Because as in solar and wind, solar generates electricity when the sun shines, and wind the same when the wind blows, but the generation of renewable energy is actually decoupled from its consumption. And for that reason, there is needed an energy storage element that would be able to store excess energy and dispatch it when on demand. So generally, the need for energy storage also comes from the change of the grid architecture, as the grid is shaping from centralized architecture, where we have one big generation facility of fossil fuel, coal or oil. And then usually we have one big energy storage asset, which is pumped hydro storage, huge facilities. And then around that, we have the network of transmission distribution all the way to the consumers. When we shift into renewable energy, we're actually shifting from centralized architecture into distributed architecture. This means that we're going to require multiple energy storage assets in different areas and locations across the grid. So as today, when we look to the future of energy storage, today we see that most energy storage is done using pumped hydro. This is a very reliable, cost-effective, and relatively clean, as it uses only water, except for a massive land that it consumes. And what we can see that the more we're going to integrate renewable energy, actually on above this baseline of pumped hydro, there's going to be multiple technologies that's going to develop and basically give solution to the distributed need of energy storage. So what we see here in blue, this is a medium or short duration energy storage, and this is longer duration energy storage. So what we see, we're going to need longer duration energy storage, meaning more than 4 hours discharge, and we're going to need that in a distributed manner. So the nice thing about what Augwind did is that actually Augwind was successful in taking pumped hydro technology, which requires massive land, specific topographies, huge water reservoirs, and huge capex in far as a project management and establishment, and encapsulated it into a small modular system that is using the same principle of pumped hydro, only we call it pumped hydro in a box, or underground pumped hydro. And this is basically the air battery. We took the major advantages of pumped hydro system and we enabled it to fit the need for distributed energy resources. And how it works. There is a water reservoir here. This is a closed circle water that's running in the system. We have pumps here, 4 pumps in this case. We have 2 compression tanks, and we have storage tanks. This is a very simple mechanism. When we want to store electricity, we use the electricity to pump water from the reservoir into the compression tanks. They compress the air as the level rises, and the air is being moved for storage here. Now, once energy is on demand, we release the compressed air back through the water tanks, and we stream the water through a turbine that regenerates electricity. So these are the same principles of pumped hydro, only instead of 400 meters of height difference between the water reservoirs, we use 40 bars of air pressure to run the system in closed circuit. This results in a very rigid and resilient system that enables multiple daily charge cycles with no degradation due to its technical nature, and also longer duration discharge depends on the quantity of storage tanks. So I can say this is air battery, or maybe I should say this is air battery. The land above the system can be utilized to any function, where we have the charge mechanism here that uses water, compresses the air and moves it to as many storage tanks as we want. The more storage tanks equals more bigger capacity. And then the discharge element, which is basically a water turbine. The fact that the system is decoupled between charge, discharge, and storage enables the system flexibility in addressing multiple applications from industrial all the way up through transmission distribution to standalone and utility scale energy storage. I want to show a glimpse of a first commercial or first demo scale installation we did here in the southern Israel. This was accomplished actually earlier this year. And this is a 1 megawatt-hour system that is buried underground in a kibbutz in the Arava part of the southern Israel. Basically, there is a very short capture here of how the system works. Maybe we're going to stay with that a little bit. It's going to make, you know, the logic of the system very clear. We see the tanks that are buried underground. Now, once we want to charge energy, the pumps pump water from this big reservoir to the underground compression tanks. The air is being compressed and then moved for storage. And then again, another cycle, as much as we want to charge, again, the system is charged and the compressed air is moved to be stored in one of those 5 storage tanks. Each tank is 250 kilowatts. Now, when energy is in demand, we release the compressed air, and the compressed air is streaming the water at high pressure through a turbine that regenerates electricity. So this is basically a very simple capture of systems operation, and this is an actual system that is operating and working now under R&D, tests, et cetera, in the southern part of Israel. And where we are basically is we are in the process of scaling up, where right now we have just concluded our phase 2 in our technology roadmap. Later this year, we're going to break ground with a bigger system already with a commercial customer in Israel. And the plans are for next year to break ground with the Israeli electricity company on a 40 megawatt hour installation for the Israeli electricity company. So this is in a glimpse, Augwind's air battery technology, and we're very happy for the opportunity, and we look for the opportunity to deploy our technology and implement it in Europe and Germany specifically. We seek to partner with partners with strategic fit to our efforts, and we'll be happy to address any questions or any additional information you might require. I want to thank you very much for your attention and time, and for the opportunity again, all the team. Thank you very much, everybody.
Thank you so much, Ido. I will just mention again that to all our participants that you can raise your questions in our chat, and we will direct them, of course, to the company's representatives. So we've heard 3 out of 6 Israeli companies by now, and we will continue further. But in the meantime, Simon, we'll back to you.
Thank you very much, Hila. Yeah, after this first set of pitches, we will now have some insights on how things are developing in Germany itself. We're very happy to have 2 industry representatives with us today. The first is Dr. Stefan Röder from the SME management company. Stefan, very happy to have you with us today. And we have Sebastian Koppenholle from Elia and 50 Hertz, who is innovation manager there, and will also introduce himself in a second. We will hear 2 short presentations from both of them on what they are doing, what goals they currently have, and how they are achieving them. And yeah, Stefan, Please go first with your presentation. We can already see it. You just have to unmute yourself.
Good afternoon, everybody. I hope you can hear me.
Yes, now we can hear you.
And I tried to share my screen. I hope it works.
Yes, it does.
Okay. Yeah, thank you very much. Warmly welcome here from Quirino's Forum in Heppendorf. Heppendorf is a very, very small village between Cologne and Aachen in the western part of North Rhine-Westphalia. And on behalf of SME Management, allow me to extend a warm welcome to you. My name is Stefan Röder. I'm the General Manager of SME Management, founded in 2012. We're independent consultant and technology company with 30 experts ranging from law to electronics, mechanicals, and as business analysts. And I'd like to give you a brief breakdown of the latest developments in the German power infrastructure. And that's why I'm trying to forward. Yes, it works. Maybe, as you know, we have very ambitious climate goals in Germany. Following Fukushima, Germany decided to shut down 8 of its 17 reactors and pledged to close the rest by the end of 2022. And in late 21, all 3 of the remaining German nuclear power plants were already shut down. So we haven't that much nuclear power anymore. And to be in line with the 1.5 degree Paris Agreement, Germany aims to become a greenhouse neutral by 2045. It's a very ambitious goal for an industrialized country as we are, as you can imagine. And it has set the primary targets of cutting emissions by at least 65% by 2030 and compared to 1990. The most important tool to cut down our emission is the rollout of renewable energy. That's why I'm very happy to meet renewable enthusiasts from all around the world in this meeting today. And we're bringing down our energy consumption, and we have a special focus on ending our use of fossil fuels in all sectors of the economy. And that means we're reducing our coal-fired power plant capacity up to 2038 up to 0. For a long time, we thought the bridge technology might be gas. But as you can imagine, after the Ukraine conflict, there's a problem. So maybe the strict planning to reduce the coal consumption will be a little bit lower. But there is a definitely goal to reduce all our capacities in 2038. And we have made significant progress on the expansion of our renewable energies since the launch of the so-called EEG, that means the Renewable Act in 2000. We have risen, the renewable energies have risen from a niche technology in Germany to one of the dominant players in the power mix. At the moment, in the power mix, about 40% are renewable energies. But all these developments have an impact on our system, as you can, power supply system, as you can imagine. And in Germany, we have, as Ashel at the beginning already told you, 4 transmission grid operators. One of them, Sebastian, is with us today. Great to having you here today. And in our area, it's not 50 hertz, it's Amprion who's responsible for the maximum voltage level. And under this grid line, we have the so-called distribution grids. And all across Germany, we have 872 distribution grid operators. So it's a very fragmented structure. On the highest level, the transmission grid operators is responsible for the grid control and the system control. That means he's responsible for the stability of the grid using so-called centralized power plants. Nuclear power plants, I already told you, they will be shut down at the end of this year. Coal-fired power plant, they will be shut down in 2038 at the latest. And they have some assets, offshore wind turbines, but they are losing their assets. In the meantime, at the regional level, I've got a problem here. Okay. In the meantime, there's a decentralized electricity supply system which consists of small PV plants, wind turbines, electrical vehicles, biomass, batteries, demand-side management from flexible production companies, high demand for green hydrogen, as well as small water power plants. And so these centralized power plants, this system is shifting into a decentralized one. And this decentralized electricity supply system in Germany has to be controlled at a regional level through an operation center. And this is our vision. In Germany, we need up to between 30 up to 40 so-called operation centers orchestrating the decentralized power production and consumption system. So that's what we need, and that's what we are building up as SME. And therefore, we created a pre-qualified ecosystem consisting of software partners as well as technological solution partners and service partners. Just a few of them are named here, and we are looking for other partners as well, not only from software, but especially from hardware. That's why I'm very interested. I listened very carefully to your report, especially Airovation technologies and Augwind, very interesting for us. And, oh, sorry, too fast. Very interesting to us. And from our control center behind me, we are servicing smart grid services. In the first step, we're defining so-called digital twins on the DSO level for and offering planning and scenario services. But based on this, we're improving on RES integration into the grid and redispatching services all across Germany. And here on the right side, you have a look into our 24/7 control center. We're making all this, but we are not only integrating wind turbines and PV installations. We are also integrating batteries, large-scale storage systems, and there's a big demand in Germany for long-term storage systems. So that's why we're interested in Airovation technologies. Last but not least, we're not only servicing municipalities in Germany, as well as industrial customers. We're also showing technologies. We're responsible for know-how transfer. This is TEPCO. This is a delegation from Ghana. And so I'm very, very happy to have the opportunity to get into touch with you from Israel, because Israel might be an interesting partner for us, not only regarding all these energy tech, but also cybersecurity. And that's why we are looking for strong partnerships in Israel as well. And we're presenting all these technology, all the demands, all the challenges, even to politicians, as our German chancellor, not only from Germany, but as well to the EU, to create a network and to make clear what is needed, how does it work, and who's paying for it. Thanks for your attention, and I'm happy to be with you here and
Thank you, Stefan. Thank you for this presentation. Very, very interesting. We will have some questions after Sebastian will present what they are doing at Elia and 50 Hertz Group. And yeah, Sebastian, the floor is yours.
Exactly. Thanks a lot. Thanks everyone. Thanks Simon. Thank the entire team for having me here. I'm really stoked for being with you guys. So as Simon already mentioned, I'm here presenting the Elia Group and also a bit of the Elia Group's approach on the energy transition, which is very clearly the big word throughout the whole conference here. And to start this off with, just for everyone who doesn't know yet, so Elia Group is active in the electricity transmission. So Elia Group is one of the TSOs, one of the top TSOs in Europe, as if to say. So we are located within the entirety of Belgium. So we manage the entire grid in Belgium. And then you can also find us in the northeastern part of Germany. So we manage the grid over there as well. And also, as was already introduced by Stefan a bit, our role is threefold. So our role is in managing the infrastructure. So these are the big overhead lines that you see in the pylons that you see along the highways. We are balancing the electricity system. And finally, we're also trying to facilitate the market as well. More concretely, what do we try to do? We try to connect the generation with the distribution. So what does this mean? We try to connect the generation of electricity to distribution to households, to industrial clients. And there are a few challenges, which already was mentioned before by some of the very interesting panelists. There are a few challenges that are coming up inside our grid. And when we look at the generation side, what we try to do is we try to emphasize sustainability and trying to steer this further decarbonization and further electrification. And then more on a distribution side, what we're trying to do is design, deliver, and operate the future transmission grid. That's what we're aiming towards, also within an integration of the European energy markets and ensuring a high security of supply. This is one of our main core tasks. And this all will be supported by this big ball in the middle that we see very important. This is the fostering of innovation throughout the whole value chain in order to meet the needs of the future energy system. And this fostering of innovation is basically done throughout the whole company, but there's one section, the innovation department, of which I'm part of, that is trying to really steer this throughout the whole company. And we're trying to do this we embarked on a new journey, and this is a journey, we say it's a journey towards the moon. What does this mean? We have set out for 5 moonshots. These 5 moonshots you can see here: system operations, infrastructure, asset management, offshore, and consumer centricity. These moonshots tackle the big challenges that we have right now in the energy ecosystem and also as a TSO. And what is this different than the things that we do day to day is these moonshots have the aim to evoke breakthrough changes, so that will solve the biggest challenges that we have right now in the field, and they go way beyond the business as usual. And we try to be supported by internal expertise, but also we really need this surrounding ecosystem, and this is also why we're present here today as well. So also, if we look in the middle section, we see I highlighted just one because of time limitations. I can't deliver every one of them, but feel free to look at our integrated reporting. I put the link there as well, which will be shared at the end of the conference, where you can look into all of these great moonshot challenges. But if you look at, for instance, the asset management challenge, you see that the goal that they have set out is by 2023, within 10 minutes, we can get to the cause of an overhead line incident. And therefore, what do? We look into the feasibility of using drones, offshore robots, sensors, and digital models. I was also very eager to see what the people at Prisma Photonics are doing, because this is also something that we're also taking into account. We also right now have an RFP tender running, where we look towards company that will actually provide this remote sensing technologies. So this is definitely something where we need help from outside of the company. And lastly, a slide to give a little bit more of the what we all do within the innovation department is we try to tackle different sections. So we have an asset management, which is taking onshore and offshore operations into account. We have consumer centricity that we focus on. We have an open innovation approach, and then we have system operations. To dive a little bit deeper into this, what does this mean? The asset management is how can we do the maintenance, how can we do the controlling of our different assets in a safe way, in an easy way. Also, what are we trying to do? We're looking into drone inspections, we're looking into robots, we're looking into the analysis of LiDAR scans, we're using AI to try and see also if we can predictive maintenance. Then also in the second section, the consumer centricity, what are we doing here? This is mostly involved with the challenge that we have that more and more of these decentralized energy resources will enter our grids. Our grid is becoming from a top-down player, it's becoming more of a bottom-up with the consumer also participating here. Here we look into different technologies that may facilitate this and can help the consumer also steer. Then we have the system operations, which is of course our main task, as if to say. What are we doing there? We're really trying to get a better grasp on how to steer this very complex electricity grid that we're now going into. You see digital operator because we need more digital data, and also quantum computing because we need to look into the future. We need to see how can we be able to handle this huge mass of data that we're going to have in the future. And then maybe last but not least, this is something that we may also talk about in the discussion later, the open innovation approach. So this is how is a company like Ido Group really going out or attracting startups in a way that will help us cope with these challenges. We have an innovation ecosystem, which is actually trying to solve certain challenges within departments with the help of study groups, with the help of universities, also startups that really help us define certain technologies and see what kind of the maturity is of these technologies. We have the Open Innovation Challenge, which is a challenge we do once a year where startups may apply to a certain team that gets set. The team for this year is sustainability. So startups apply, they can get they actually get funneled to they do an open application, they get funneled, and then finally the winner of this competition receives a sum of money and also gets to cooperate within our incubator and develop this project further with the Ido Group and being supported by Ido Group as well. We have done some startup scouting that we do as well. And then we have ideation and design thinking to facilitate all of this. And then a very interesting thing is we have different labs as well, where we try to gain our own expertise to really support all of these technologies. So we have AR, VR lab, we have an Internet of Things lab, we have a distributed ledger technologies lab, a tech lab, which is basically trying to support the innovation and trying to really make this energy transition possible through innovation. But I think Simon has some very interesting questions ready in the discussion session as well. So I'm gonna let him share those.
Thank you, Sebastian. Thank you very much. Yeah, thank you both for this very interesting presentations. Since what is the most relevant is how we get actually to do things and how things will happen on the ground. I would like to ask you to give an example. Maybe Steffgen, you can begin of how there was some successful implementation of external innovation in one of the projects you managed. How the process was. What your role in this process is, because you said there are so many stakeholders in this area, and this makes it problematic to really speed up the change. Maybe you can give one practical example from one of your projects. Can you unmute yourself? Thank you. Perfect.
Thank you very much for this interesting question. Just one example, we are supporting a Swedish manufacturer of PV battery systems for the commercial and private customer market. It's a system without lithium-ion batteries, so there's no fire problem. This is one of its USPs. and we're making the whole product process ready to market for Germany, and we're matching them with our customers from the municipality side. This is just one example, and we're supporting the complete whole rollout. Another example is that we have some problems with long-term storing of renewable energy and making it available. So we have the storage, long-term storage system combined with a turbine, and we supported the implementation into the grid and making the whole business model out of it. So we are very hands-on. Yes, as you have seen, our core competence isn't PowerPoint. We're not PowerPointers. We're hands-on. We're seeking for. We're listening to our customers and their problems. We're seeking for the right technology, and put them together. And we are managing this project from the first point up to the rollout.
How relevant do you think is the mediation role of yours in this process? Because there are so many stakeholders like municipalities, different technology providers. Can you say one word on how important it is to have such a management in between?
Yes, there is a lack of management capacity within the municipalities in Germany for innovation projects. The other point is the market is very fragmented. So external partners from abroad do not have a deeper understanding into the German market structures and how it works, whom you have to talk to. And the most important point in Germany is to have a reference project, a pilot. Yes, you have to make it tangible. Yes, that's the main problem. And from the other side, the municipality employees are not able to realize such projects in a very short time. So this is a problem. They do not understand each other. So we are not only supporting in the management business line, we are also supporting the communication process, which is very, very important to get into the market successfully.
Great, thank you. Thank you. Sebastian, maybe you can also give us a practical example, maybe of one of your innovation challenges and how the onboarding process went. Maybe you can also elaborate a bit on what kind of startups you're looking for and what stages you're onboarding them. Would be great to hear some hands-on experiences here.
Exactly, indeed. Thank you, Simon. So I think it's a bit to set a bit of a small framework is I think it's important to see what we look at is we sometimes as Ilia Group innovation departments, we often go out and try to find startups. So we go into conferences, we go to Endit, we go to Enpri. We really try to reach startups that way and try to see, okay, how can these startups help us solve challenges? We have this innovation scouting that I told you that we say like, okay, we try to test the level of maturity of a technology by going out and finding players that or startups that have this technology. But what we're also doing is we're trying to also provide an inflow, provide this funnel for startups to really come in. And this is something where, for instance, I remember very early in the presentation, Esther mentioned hackathons. I almost forgot about these, but we also do these during the year as well. We have hackathons where we have startups that can just join us and start to collaborate on a certain challenge we have. But then next to this, there is this open innovation challenge that is, we've been doing this since 5 years, and it's basically a big thing. It's becoming a big thing where a lot of starters participate, and we really want to create this funnel. But we also, what we want to do is we also want to foster these startups. So we also, as you say, like, how do you actually guide these startups? We don't care what level the starters are at, but what we're trying to do is we want them to provide the technology that is a breakthrough, a technology which is new to us and that can help us get further as well. And this is why we try to also give them expertise that we have. So we try to create value creation on both sides. We want them to give us an innovative solution that we can actually use in our challenges. And we want to support them as kind of a test bed where we provide them with expertise, technical expertise, regulatory expertise. And then to really give a concrete example here, so one of our last Open Innovation Challenge was about the offshore wind integration. That was the big theme. And a startup from Rio de Janeiro, or a small startup from Rio de Janeiro, Tidewise, has won this challenge. And what did they do? They developed an unmanned vehicle, which is doing inspections from the air and under the sea, which is basically gathering data, making analysis, also with AI, that makes it easier for us to do maintenance and control certain assets in a safe way. And they are right now, so they were onboarded with us because they won the challenge. And they're right now, I think in about a month, they're going to start really testing and also already implementing these on our assets. So this is a way in which we really funneled through this Open Innovation Challenge, providing them with the right expertise, providing them with the contacts and everything they need to then finally be onboarded with a challenge that we actually have.
Great, thank you. Thank you. We have to keep, unfortunately, we have to keep time. Maybe one very small word on how do you see change picking up at the moment, Stefan? Maybe one sentence on this. Are you optimistic about achieving change in the next months and years? Can you unmute yourself?
I'm very optimistic. The Ukraine conflict is a booster for the German electricity supply market. It's like that. So we have to integrate renewables. It's one topic. We have to store renewable energy, and we have to make it available 24/7, 365. These are our key issues, and we're seeking for partners from all around the world who can help us. So I'm very optimistic.
Great, thank you. Sebastian, maybe one sentence from you.
Yeah, I think I can just echo what Stefan said. I think we have such a big challenge ahead of us. Also with the rise in electrification, there's a lot of energy going to be needed. As a TSO, we really see some hurdles, some big hurdles that can only be solved by real innovation happening. And we really also need, as also Stefan said, this international inflow of startups coming in and really helping us to get over those hurdles and to really tackle this challenge the best way we can. So I think I can only echo what Stefan said.
Okay, great to hear that you're optimistic. So we're very much looking forward to both collaboration and to seeing the results. And we'll be happy to connect you with the Israeli ecosystem. So without losing any further time, I would like to hand over again to Hila, and let's have the second set of our Israeli companies. Hila, please.
Thank you. Thank you, Simon. So we would like to continue with the fourth subsector, which is storage, which is a subsector that, of course, gains a lot of attention lately. So I would like to introduce you to Tal-Gutemacher, the Business Development Director of Brennmiller Energy. Tal, the stage is yours.
Hello, everyone. Can you see my screen?
Yeah.
Good. Okay, so hi, my name is Tal. I am from Brennmiller Energy. Brennmiller is a thermal energy storage company founded 10 years ago by Avi Brennmiller. Avi was a former CEO of an Israeli company called Solel, which did solar thermal projects back in the 90s, in the early 2000s, hundreds of megawatts in Europe and the US.
Make sure the Samsung Gear app is active on your phone.
The Israeli company Solel was acquired by Siemens in 2009, and Avi was appointed the head of CSP operation in Siemens. And after retiring from Siemens in 2012, Avi and the rest of the team have started Brennmiller Energy, which focuses on developing manufacturing and selling thermal energy storage solutions. We have raised over $90 million up till today. We are 70 employees here in Israel, and we are a public company since 2017. You can see here a part of the team. Our technology is about storing heat at high temperatures in the media of crushed volcanic rocks. We crush and compress these rocks into these types of modules, which you see here in the picture. These modules contain the crushed rock, which is crushed into sand-sized particles, and then filled into a type of pizza trays, which you can see on the top right, which assemble these modules. We stack about 300 of these cells into one module, and you can see the pipings which carry in and out the energy in and out of the modules. These modules are prefabricated in our manufacturing plant in Israel, in Dimona, and then shipped and assembled on site, on the project site, according to the size, the capacity, and the power which is needed for the project. Our unit is actually a combination of thermal energy storage combined with a heat exchanger and steam generation, all into one unit. Very green and clean solution. There's no chemicals or salts, no hazardous materials, nothing that could explode. Very modular. As you saw before, we can start relatively small with 2, 3, 4 megawatt hour and go up to hundreds of megawatts by assembling more and more modules. There's no degradation of the materials. There's no cycling effect to the solution. So we can provide a very long lifetime of over 30 years. And this is essentially built out of rocks, metals, and pipings, relatively low-cost materials, which allows us to bring quite a competitive solution to the table. The way that it works is we can charge our energy storage unit either electrically, coming from renewables, PV, wind, or from off-peak electricity. Inside the modules, we have embedded electrical heaters which convert the electricity into heat at very high efficiency, over 99% efficiency in this process. Since the electrical heaters are embedded inside. So this is one way of charging. A different way is charging thermally. We can use different sources of thermal inputs like biomass, biogas, CSP, steam, almost waste heat, almost any type of high-grade heat source we can utilize to charge the storage. When charging thermally, we circulate this heat inside the storage modules. The heat is transferred into the storage media. And then on the discharging cycle, we have water, which is introduced into the system, circulated inside and boils, and comes out as steam. We can control the conditions of the steam, the temperature and the pressure, and provide from low-grade industrial condition steam, let's say 200 degrees or so, and go up to superheated steam, 500 degrees, 100 bar to drive a steam turbine and generate power. So, so these different inputs and outputs, we can deliver several applications for our technology. We are targeting today 2 different markets. One is the industrial market, industries which consume a lot of thermal energy, mostly in the food sector, chemicals, plastic, paper, these types of industries. And our second market is thermal power plants, both gas and coal power plants, which I will explain in a minute. So in the industrial sector, it is very heavily based today on fossil fuels for their heat generation. As you can see, about 74% of the industrial energy consumption is actually in the form of heat and not electricity. And over 90% of this heat is generated from fossil fuels. And this is the main challenge here of decarbonizing this heat and introducing more renewable sources to generate more clean and renewable heat for this industry. So this is one of our targets. The way that we do it is instead of the traditional way of generating heat, or it's mostly steam, which is based on fossil fuel, which is burned on demand. We couple our storage solution together with renewable sources, which is very intermittent source. When coupling with thermal storage, it becomes much more stable, much more reliable, and you can decouple your energy input from the consumed energy from the output. So on the left, you can see an example of a unit which is being charged from a PV source. So input is during solar hours, and the output is on demand throughout the day, 24/7. On the right, you can see here a different type of system which is charged during off-peak hours during the night, and then dispatches energy throughout the day, again according to demand. So decoupling inputs from outputs is one of the major advantages for storage. A couple of projects to show. On the left, you can see a project which is a type of cogeneration unit. You can see here a gas turbine which is feeding a university campus in upstate New York. We are actually collecting the heat, the exhaust heat from this unit to heat up the storage unit. And then we are delivering, in this case, hot water to the university campus. So again, decoupling electricity generation from heat consumption allows much higher efficiency for this cogeneration unit. I'll try to move ahead as I see I'm running out of time. I'll just mention this project. We've recently signed a project with Philip Morris, which is biomass-based in Romania. For power plants, we have two different offerings. One is for gas power plants and one is for coal power plants. For coal, actually what we are aiming is to replace coal-fired boilers with our storage unit. And then we can, in this case, we can transform old and retiring coal plants into grid storage facilities by utilizing the existing infrastructure, which is on site for this coal plant. So utilizing the real estate, the turbines, the grid connection, and so on, and just replacing the boilers with our storage, which is fed from renewable sources. So we think this is a good application for our technology. And for gas power plants, I'll try to skip some slides here.
We are running out of time. Sorry for the interruption. So please, yes, 1 minute and we are.
Okay, so just to show our my last slide here. This is a project we are doing with Enel in Italy, a 24 megawatt hour storage solution in a combined cycle power plant, allowing energy shifting, faster ramp up, and different services to this power plant. This is under construction these days. So I will finish with that. Thank you very much.
Thank you, Tal. Thank you very much. And without further ado, we would like to move on to the hydrogen sector. And I would like to introduce you to Dr. Ervin Tal, the CEO of Hydrolite company. So go ahead, Ervin.
Hello, everyone. Good afternoon. And let me share the screen. Can you see my presentation? Can you see my screen?
Yeah, yes, we can.
That's perfect. Okay, so hello, everyone. Thank you, Ila, and thank you, everyone, and Simon for giving me the opportunity to present here. I will try to be brief and use the upcoming minutes into giving you all a glimpse of what we do at Hydrolite. Practically, what we do, we develop hydrogen-based technologies for storage and conversion via our advanced alkaline exchange membrane fuel cell and electrolyzers. Hydrogen has become a buzzword in the green energy sector in the last couple of years. And that is not only due to the regulations, because hydrogen is the only carbon-free fuel complying totally with the net zero imperative fostered by 75 countries comprising 50% of current world GDP. Not only the governmental sector with the CO2 pricing mechanisms have embraced hydrogen, but also the economic sectors with the finance, companies looking at hydrogen as a long-term investing opportunity. This is why, for example, in the last report of McKinsey, $700 billion are perceived to occur in hydrogen investments through 2030, with a market which is will grow extremely from hundreds of billion-dollar markets per year to trillions of dollars of markets in the upcoming couple of decades. So when we look at the full hydrogen ecosystem comprising of three practically chains, the production, the distribution, and the end-use application, we at Hydrolite have developed advanced technology that practically is applicable for both the production sector segment and as well as the end-use application of hydrogen as the fuel, as carbon-free fuel of the future. Now, who we are at a glance, the company was founded in 2016 here in Israel as a spin-off from Elbit Systems. Elbit Systems is the largest private electronic defense company in Israel and among the top 35 worldwide, and currently we are fully owned by them. The company is a relatively small one. We are currently 20 team members, fully devoted to technology development and maturing, while all the other services we receive from our Elbit metrics. During the years of the company and technology development, $50 million have been invested in the company, with 10 million of those being public funded grants, non-dilutive ones. We are very involved in recent Green Deal and Horizon 2020 programs. As an R&D company, we take pride in our comprehensive IP portfolio comprising 69 patent cases. 51 of those are already granted worldwide, and we have more applications in the pipeline. This portfolio practically covers the whole alkaline exchange membrane technology domain, from the core materials for cells, stack, modules, and up to system level. We are located in Caesarea, spread through 1,200 square meters of facilities, equipped with scientific laboratories, state-of-the-art equipment that allows us to make full development and evaluation of both fuel cell and electrolyzer device. So what is our technology? We did not invent the fuel cells. We did not invent the electrolyzers. These are practically devices that have been invented decades ago. What we did have invented and been pioneers is a disruptive approach of an alkaline membrane applicable. We first applied it for a fuel cell device, and recently in the last couple of years, we actually also exploited it for the electrolyzer development. So the benefits that this disruptive approach brings on the table is the combination of a high performance device in terms of the efficiency, dynamic behavior, intermittence, and the fast turn on and off, combined with a low cost materials embedded or practically being resulting from the alkaline environment, embedded in our low-cost electrodes with low-cost catalysts, embedded in our inexpensive hardware comprising low-cost materials such as aluminum with simple coatings, and of course the chemistry, the heart of the membrane being derived from a hydrocarbon polymeric family. So we have two applications. The first one is our fuel cell device, which you see here in this picture. It's practically our 5 to 10 kilowatt stationary fuel cell power generator, operating at an efficiency ranging from 50 to 60%, depending on the operation point. With this system, we are targeting stationary markets such as the residential sector, mobile towers. Practically, you can look at this fuel cell as a battery charger that can serve either for mobile platforms or stationary platforms. We are involved into demonstrating this capability in an electric vehicle range extender. And since this is a modular, this is a modular system being capable to be scaled up to tens of kilowatt, up to 100 kilowatts building block, then with that, one can further address market segments for large power outages such as data centers, etc. The benefits of this technology, as I said, result from the alkaline exchange membrane domain, depicted in low capex and opex. The system practically allows long backup times from several hours up to several days, with a lifetime ranging from 10 to 15 years. And it's a totally green system, quiet, without any toxic or problematic emissions, and 95% of the system is recyclable. The second application is the alkaline exchange membrane electrolyzer that we have developed for green hydrogen production. The electrolyzer is practically a mirror device of a fuel cell if the fuel cell uses hydrogen and oxygen from the air to practically convert those into electricity with only water as a byproduct. The electrolyzer does exactly the opposite, uses the electricity coming from a renewable source and splitting with it water to hydrogen and oxygen. We've been capable of demonstrating quite a high performance in terms of the efficiency, 45 kilowatt hours for 1 kilogram of hydrogen production with our alkaline exchange membrane electrolyzer, at a quality of hydrogen gas of 99.999%, so rather pure. A very proprietary strong benefit of our technology is that we can use low water quality in terms of the water pureness. So we can work with tap water, we can work with brine and breakage water, and this is totally unlike the competitor PAN technology, which practically requires deionized water. This strong benefit opens a lot of opportunities, since we, especially when we look at the recent usage of electrolyzers for hydrogen production and energy storage in offshore platforms. That is practically very applicable, since we can practically split saline water as well with our technology, patented technology. So when we look at the benefits of the AM electrolyzer technology, as I said, it's a combination of high efficiency and low cost. So when we look at the capex of such a product, it's approximately $500 per kilowatt, with a production cost of green hydrogen approaching the gray hydrogen cost. So even going for the gigawatt scale, approaching the $1 per kilogram. That does not include the electricity cost. And of course, it's totally green without any CO2 emissions.
Sorry, but we are reaching our
this is my last. So this is my last slide. So when we look what is our unique standalone market position, these are the players that practically are devoted to the fuel cell and electrolyzer. There are not so many who are dealing with both technologies, and this is practically what we have at Hydrolite, the capability of combining both the fuel cell capabilities and the electrolyzer capabilities in an AEM emerging technology domain. We are currently searching, this is the roadmap, and we are currently searching for strategic partners that will help us promote the roadmap, make joint projects for pilot establishing and demonstration, and mass manufacturing and further industrialization of these technologies. So you can have more information in our website, and please, we are here if you have further questions. Thank you very much.
Thank you, Ervin. Thank you so much. So last but not the least, I would like to welcome Zvika, the founder and CEO of TIGI Solar. Zvika will represent the generation subsector. So Zvika, the floor is yours.
Thank you very much. I was wondering why he selected me last. I feel a little bit like I'm in between you and the coffee at the end of the session, so bear with me, I'll make it quick. TIGI is about 10 years old, is a supplier of technology and turnkey solutions for renewable heat, especially for large heat users. We have put in place dozens of such projects, especially for industry, for hospitals, for army bases, for hotels, etc., etc. The point of heat is I believe, extremely important, and was mentioned briefly by Tal before, and I think also comes out of what Dr. Röder mentioned before as it relates to the Ukraine. We all talk and hear about renewable energy all the time, and most of the time this is around electricity. If you look at the, obviously, photovoltaics and wind, and most of the storage that we hear about is focused on electricity. But if you look at the way the world uses energy, or the way it gets its energy, you'll find that less than 20% of the world's energy comes over an electric grid. The two other large energy players here, one is transportation. Most of it, we go into a gas station and we get gas for the cars and ships and planes. And the other is heat. And heat is still, as we've seen in the presentation before, still primarily done by burning of from gas to oil and coal. And the participation of renewable energy there is relatively low. We know of solar thermal collectors doing shower hot water for in the Sun Belt and some other, but mostly again, this is around fossil fuels. And there is need for technologies that generate green renewable energy at higher temperatures than shower temperatures and in colder climate conditions. If a company came around with a solution in this domain, that's a very big opportunity. This is what TIGI was built to solve. Initially, we have developed a new type of solar thermal collector that generates heat. And it is focused on solving the reason for which solar thermal collectors don't work in cold climate conditions or at higher target temperatures. These collectors are normally not very well insulated, and they are not insulated primarily on the sun-facing side because you need to let the sun in. This is also the place where most of the losses occur. And TIGI has developed a transparent insulation solution that allows the sun in, but doesn't allow or minimizes losses of energy out. And the result is that it works even when it's very cold outside, or if you need much higher target temperatures. TIGI is now focusing on up to 100 degrees Celsius, although the technology is capable of doing more. The need for higher target temperatures is not primarily in residential. It is primarily in industrial, in agricultural, in commercial uses. And we have obtained certifications for Europe and the United States. This is protected by dozens of granted patents. It is much more complex than what I'm explaining right now. And the result of having a much, much better collector leads to a lower cost kilowatt hour. And it's lower cost than any other alternative in most situations. Collectors are not alone. There is a very big difference between most scenarios where collectors are installed and industrial applications. And our background is, in fact, it's a team coming from chemical textiles industry, really understanding heat of large heat users and experts coming from high-tech industries. And we have built a very elaborate solution that is engineered to optimize not only generation, but also storage with everything related to simulations, configurations, optimization from remote, services from the cloud. And these systems are what we're currently supplying. Part of the services in the cloud, we also measure the energy that the system generates from remote and can optimize it, but can also work in a business model of actually selling the heat rather than selling the systems. Most renewable heat systems are small, residential, and therefore everything that we know about financing in renewables, which we know from photovoltaic fields and from wind and from storage, is not currently playing a strong role in heat. And since the systems that we do, and you can see a few of them over here, are larger, they are supplied to larger organizations. Again, there would be hospitals or hotels or industry or agriculture. There is an opportunity to finance them, and then the customer can get lower cost energy from day one without investment, and it's good for the environment and good for regulation. Obviously, with prices of energy and the level of motivation right now in Europe for renewables post Ukraine and everything else that we know, COP26, etc., the alternative cost of energy is very high, and there's a good opportunity to finance such solutions. This is just to give you an example of a system. This is a winery. It's the third largest winery in Israel. We supply year-round water at 85 degrees Celsius for washing of wine barrels and other processes that they have. With return on investment of about 4 years for something that has a life of 25 years, and it doesn't eat anything. It's all based on the sun, saving 70% of all the fossil fuel that they used before we came. I mentioned the business model. I think that would make a very big difference. We expect that people they invest in things and they invest in renewables, but they don't usually want the capex in their books. The fact that we trust our equipment reduces the risk, and that we can finance it, I believe, will make it much easier to implement at large scale. Our plan, since taking the company public in Israel about a year ago, is to come and become a bigger player in Europe. We have already put in place a couple of systems in Germany and in Norway and the UK, but we are restarting this effort with much more energy and the financing that's needed, looking for partners to put this in play for the right kind of customers. So thank you very much.
Thank you, Zvika, and thanks to all the 6 companies that were presented here. Simon, getting back to you for
thank you very much, Hila.
Wrapping up.
Yeah, thank you very much, Hila, for presenting the companies. Thank you, everyone in the audience for being with us. We are looking forward to connect to you. Please feel free to approach us on LinkedIn, send us an email, and subscribe to our newsletter where we can keep you posted on a monthly basis on the ongoing events. And yeah, of course, stay tuned for what is going to happen within the German-Israeli Energy Partnership. And yeah, let's tap into the synergies that are there and speed up the change in the energy system. And yeah, it was a pleasure to meet you all here today. And hopefully we'll be in touch. Soon. So have a nice afternoon in Germany, Israel, and wherever you are. Bye-bye.
Bye-bye.
Thank you very much.
Bye-bye, everybody.
Bye.
Thanks a lot.